Hello everyone, welcome to the class of Pine Language Quantitative Trading Practice series of tutorials. Time series in Pine Language is a very important concept. In this course, we will explore the concepts and knowledge of time series in the Pine language. We know that in the Pine language, the strategy is based on the chart. The most basic content displayed in the chart is the K-line. Each value on the time series has a time associated with the K-line bar. Let's take a built-in variable open as an example. The structure of the data series open stores the opening price of each K-line in the chart. We can understand that time series structure of open represents the opening price of all K-lines from the first bar at the beginning to the bar where the current script is executed on the current K-line chart. Let's take this K-line period of 5 minutes as example. When using open in the Pine language strategy, it is equivalent to use the K-line opening price with a 5-minute K-line period. If you want to quote historical values, you can use the quote operator. Next, we will demonstrate it in our backtesting system. Entering the strategy library and enter open 1. In the strategy editing code box, which refers to the opening price of the previous K-line bar at the current execution position. If you write open 2, which refers to the opening price of the first 2 K-line bars. Let's demonstrate the time series with a simple example. First, declare a variable named VE and initialize it to V1. Then it will be 1 on each K-line bar. Then we declare a variable v2 and initialize it as the return value of our function. V1 is a time series based on variable, and we can pass V1 as a parameter to this function, then accumulate all its values on no K-line bars, and then assign it to V2. And we can draw the variable on the chart. The specific value of each K-line bar changes as the chart strategy is executed using the plot function. If the first K-line I print the data of V1, name it as V1. If the first, then draw a line to fill with data 2, data V2. And name it as V2. Then we draw a few more lines as reference for comparison. Taking the value of the previous k-line bar of V2, which is a k-line bar on the corresponding value of V2. That is its reference historical bar, which we name it as V21. Then we draw another line for reference. You can print out the bar index. It starts from 0, and the bar index and the index of the first k-line becomes 1. So here plus 1 in order to increment backwards, and we name it as bar index plus 1. And then we click backtest. Don't forget to set the time range. It's the beginning time and the end time, and set the k-line period at 1 minute. And click backtest. Here we can see the results. There are several lines that have been printed out at this position. We pull the chart to the far left and look at the first value. V1, no matter which k-line bar is on, V1 is always 1 here. Even if the strategy runs to the end, V1 is still 1. Therefore, V1 is a fixed variable. Then we look at V2, which has the first k-line value of 1 here, and the second k-line value of 2. Why does it change to 2? We can look at the function in the code. Calculation of V2 is to add up all of V1. That is, when the strategy runs on the first k-line, V1 is 1, and the value of V2 is to add up all of the values of V1 on the k-line data series so far. So on the second bar, the V2 value is shown as 2, and so on. At the end, the variable before V2 references, that is V21, is NA, and on the second k-line, V2 has a value. We can see that V2 on the first k-line is 1, and V21 on the second k-line references the V2 value of the first k-line. So the red line drawn always lags behind the blue line, and the blue line is always lags behind the V2 line, because the blue line is bar index, which overlaps with the V2 line. The purpose we draw bar index plus 1 is to mark the first k-line. with the value of 1 actually, the second with 2, and so on. So bar index plus 1 is always changing synchronously with V2. And the value of both are exactly the same. So why is this? The reason is simple. There are four k-lines. Each k-line is 1. And after adding them together, it equals to 4. Bar index plus 1, which is also the number of k-lines. So when the strategy runs to the end, it has 304 k-lines. We can see that the bar index of this k-line is 303 because the index of the first k-line is 0. After the last k-line plus 1 is 304, which means the 304th k-line, which means that V2 has accumulated for 304 times. So this is the concept of time series. And these variables we created are run based on the concept of time series as a structure, whether it's set up as a bar model or tick model. Why should variables be designed in such a structure? For example, when using built-in functions such as ta.cum, it's very convenient to write the strategy by passing in just one variable, and then it will iterate over the entire time series automatically. If I want to calculate the average price of all the k-line bars, then the first value is created as V1. Use the function ta.cum, passing in the built-in variable of close. And it accumulates the closing price of each k-line bar. Then declare of the variable average price to calculate the average value. V1 is the summed number divided by bar index plus 1. So we can see the first k-line is 1. The second k-line is 2. That is, the script runs to the position where bar index plus 1 represents the number of k-lines. The average value is the sum of the calculated sum divided by the k-line. We use the function plot to print out average price, name it as average price. And we use the function plot to print out average price. Then click on backtest here. Here we can see the drawing demonstration. There is an average data in the chart. It is shown on the subchart. Now let's update it to the main chart. And we click backtest again here. And we can see that is equivalent to an average line drawn on the chart. This is also a method that may be used when we write strategies. The TA.com function can pass not only built-in variables, but also expressions combined by operators. For example, if I want to calculate the difference between the highest and lowest price of each K-line bar, and then perform a moving average calculation, if I want to find the difference moving average, I can write differ average equals to TA.SMA, so that I can pass an expression that uses the highest price of each K-line minus the lowest price built-in variable to find its 14-period average. And then print diff average, name it as diff average. Here we click backtest. And then we can see the difference value points out a line, but it is not appropriate to draw it in the main chart because the difference is less than 100. We generally draw it on the subchart. The result of the function call also leaves a trace of the value in the time series. We can demonstrate this with another example. Declare a variable v1 and assign to it a value with the TA.highest function. Which is actually the highest value of the K-line in a certain period in the past. At this point, we pass in the built-in variable high, which is the highest price on all K-line bars. Then specify 10 periods referencing the historical data calculated by this function. And then declare a v2 variable. Here we also use the TA.highest function to assign a value to it. But at this point, instead of passing the built-in variable high, we pass in the sequence value of high on the previous k-line bar. Of course, the high of the previous k-line is also a time series structure. Again, we use the data within time periods here. So will the values of V1 and V2 be equal? If you think they are equal, you can type 1 in the pop-up. And if you think they are not equal, you can type 2. We print out this value by the plot function, name it as V1, and let it display on the main chart. And then we draw a line, pass into V2, name it as V2, and let it display on the main chart as well. Here we click on backtest. And we can see our correct answer. We put our mouse on the chart and we can see the values of V1 and V2 are always synchronized on the far left side of the chart. Why are these previous ones are not? Because we are calculating within 10 periods and we can't calculate it if the condition of 10 periods is not met. Only when it meets 10 periods, the result can be calculated. So here the value does not appear until the 10th bar, and the orange value and purple value are always the same. So the values of V1 and V2 are always the same, and this line drawn on the chart is always exactly overlapping. The result of the function call is a structure based on time series, which also leaves traces in the time series. So when quoting the data of the previous one, it is equivalent to use the data of the previous bar to calculate. The maximum value of time periods is exactly equivalent. The result of the calculation of the function call can also refer to its historical value with 1. The result of the highest calculation is based on the previous k-line bar on the current k-line bar. That is, the result of the highest reference to the historical value 1 passed into the calculation. So the results of the two are exactly equivalent. In addition to drawing lines in this way, we can also put the specific price on a K-chart, which is easier to observe. This is another way to test it. We change the strategy and use the plot chart function. The plot chart function to draw the chart, pass the first parameter to true, name it as v1. Use the toString function of string, converting v1 to a character, and output it into the chart. Use location to specify the location of the drawn chart. Draw the value of v1 above the k line. And specify the color v1 as red. Let it display on the main chart. Let's draw a second line. Name it as v2. Specify the location below the bar. And specify the color as green here. Let it still draw on the main chart. And we click Backtest. And we can see that the chart in the backtest result, the data are all marked on the K-line bar, and the data marked on each K-line bar are red. That's to say the values drawn by v1 are green, the values of v2 are completely synchronized, and the values on each K-line are exactly the same. You can make a function call first and then take its historic value, or pass in the historic value of a variable to be computed during the function call. So that is an equivalent call. This gives us a clear understanding of the concept of time series in the Python language strategy. Finally, thank you for your like, follow, and repost. Your support is our greatest motivation.